Here is a solution for day one. Given this function, question A, determine the left end behavior. That means if we were to graph this on the coordinate axis, what would the left end of the graph look like? We can predict this without first graphing it. First, we need to know the highest power. This goes to the second power. This is going to be a quadratic equation. The graph is a parabola. Next, we look at the leading coefficient. The leading coefficient is a negative number, so it's an upside down parabola. The left end of the graph is going to look like this, and then it's going to curl up and then come back down. So we want to describe this in symbols. As x approaches negative infinity, that means on the x-axis, as you're moving to the left forever, this is how you describe the left end, g of x approaches negative infinity. This describes going downward forever. So in symbols, this is one way to describe that the left end of the graph is going downwards forever. Question B, determine the right end. Well, if you envision that it's an upside down parabola, then the right branch looks like this. Now, how can you show that in symbols? As x approaches positive infinity, that means as you're going to the right forever, g of x approaches negative infinity. This means the function is going downwards. Question C, determine the real zeros. We could graph the function and then find the x-intercepts, but we don't have to. We can find the zeros using algebraic methods. One technique is the quadratic formula, where you fill in values of a and b and c, and I've done that here. Working this answer out on the calculator, -2 is a 0, and 0.83 repeating is a 0. By the way, this is the same as the fraction 5/6. Determine the y-intercept. We don't have to look at the graph to see where it crosses the y-axis. We can figure that out just by looking at the equation. If you fill in 0 for x here and here, that leaves the constant number as the y-intercept. So the y-intercept is at 5. Now let's actually look at the graph and check that our predictions are correct. Pull the calculator onto the screen. Got the function typed in and push graph. Notice it is in fact an upside down parabola, so the left end behavior is that it continues to go down forever. The right end behavior is that it continues to go down forever. There's a 0 at -2 and a 0 here at 0.83 repeating. And we can see that it's crossing the y-axis up here at +5.